Good morning, students. Today we will start a new chapter, Chapter 6, Geometrical Optics. What is meant by optics? That is the branch of physics that deals with light. And what is geometrical optics? That is the branch of optics where light is considered as a ray. Light travels in the form of a ray in a straight line through a homogeneous medium. So, in this chapter, there will be a lot of drawings because we consider light as a line or a ray and represent it as a line. And we will also see what happens when light passes through a prism, lenses, and when light gets reflected by mirrors of different kinds. And we will also see the working of microscope, telescope, etc. So let us get into the chapter. And the first lesson, we will deal with what we have learned before. This will be just a review of few concepts we have learned in the lower classes. So let us see what is reflection, refraction, and we will also see something about the images formed. What is reflection of light? When light passing through air or any transparent medium is obstructed by any other medium, then a portion of light returns to the first medium. This is called reflection of light. Here you can see in this figure, light is coming in a medium, say this is air, and while traveling, it gets obstructed by a mirror. Then what happens? It gets reflected back. It's our usual experience that when we look into the mirror, we can see our own reflection. So this happens due to a phenomenon of light called reflection, which we are really familiar with. And there are few laws of reflection. The first law states that the incident ray, the normal at the point of incidence, and the reflected ray lie in the same plane. So here you can see the incident ray. Normal means a line making 90-degree with the surface, and also the reflected ray. All three of them lie in the same plane. Now, the second law states that the angle of incidence is always equal to the angle of reflection. So here, angle of incidence is the angle between the incident ray and the normal, here represented by the letter I, and angle of reflection is the angle between the normal and the reflected ray. It is represented by R. So angle of incidence will be equal to angle of reflection. This is the second law of reflection. Now let us see about different kinds of mirrors because reflection usually happens in mirrors. What is a mirror? A smooth surface from which regular reflection of light occurs is called a mirror. And we have seen different types of mirrors, plane mirrors and spherical mirrors. The usual mirror in which we see ourselves is a plane mirror, while mirrors which we can see as a rear view mirror for a vehicle, that's a spherical mirror. So let us see what are the different kinds of mirrors. So this is a plane mirror. We keep the object here and we can see its reflection. Now, spherical mirrors are mirrors whose reflecting surface is part of a sphere. So, if you consider a large sphere, then a small part of it acts as a mirror. For example, this is an example of a concave mirror. In order to remember the name of the mirror, cave, I have shown here a person living in cave. So, it's in the shape of a cave and the object should be kept inside the cave. That is, the reflection should occur from the inner surface of a hollow sphere. Here, these lines show the polished outer part or the rough outer part. We may also call it silvered part. So, this is the silvered part or the polished part, and here reflection occurs in the curved inner surface. So this is called a concave mirror. And when the reflection occurs from the outer surface of the sphere, here you can see the object is kept near the outer surface and the reflection happens from the outer surface. So the outer surface will be smooth and the inner surface will be polished and rough. So here the reflection takes place from the outer surface and it is called a convex mirror. So, mirrors are smooth surfaces from which regular reflection of light occurs, and there are two types of mirrors, plane mirrors and spherical mirrors. Spherical mirrors themselves are classified as concave mirror and convex mirror. So reflection occurs in mirrors. Now what is the other phenomenon which we are going to learn about? That is refraction of light. I'm going a little fast because you have learned all these in your lower classes. So refraction of light means when a ray of light travels obliquely from one medium to another. What is meant by obliquely? Obliquely means making an angle less than 90 degree. So here you can see two medium. One medium from where a light is incident making an angle less than 90 degree. So this is called the normal. Normal is the line making 90 degree with the surface. So the angle of incidence is the angle between the incident ray and the normal. Now, one condition for refraction of light to occur is that the light should travel obliquely, that is making an angle less than 90 degree. Now, if the light is traveling along the normal, will there be a refracted ray? The light will travel along the normal and there will not be refraction. That is, there will not be bending of light because the bending of light at the surface of separation of two media is called refraction of light. So what is refraction? When a ray of light travels obliquely from one transparent medium to another, the bending of light at the surface of separation of two media is called refraction of light. So that is one condition. If the light is traveling along the normal, there will not be bending of light. Only if it is making an angle less than 90 degree with the normal, there will be a refracted ray. Now, there are two laws of refraction. The first law, similar to the first law of reflection, states that the incident ray, normal drawn at the point of incidence on the surface of separation, and the refracted ray lie on the same plane. Simply, you can tell that the incident ray, the normal, and the refracted ray lie in the same plane. And the second law of refraction, which is also called Snell's law because it's put forward by the scientist called Snell, it states that when light enters obliquely to a transparent medium from another transparent medium, then for a fixed pair of media and for a fixed color of light, the ratio of the sine of angle of incidence to the sine of angle of refraction always remains constant. So you must have learned this Snell's law as the ratio of the sine of angle of incidence to the sine of angle of refraction is equal to a constant which is called the refractive index of the medium. Now here I have mentioned two conditions, that is for a fixed pair of media and for a fixed color of light. This is because the constant depends on the media in which this occurs. If you take light traveling from air to water, the constant will be different from the case when light is traveling from air to glass. Or if light is traveling from water to glass, then also the value of constant will be different. So the value of constant depends on the pair of medium. And also the value of constant or refractive index is different for different colors. That is why when light travels through a prism, it gets separated to different colors. So each color for a particular medium have a different value for the refractive index. So this constant will be different if you are using a red color light, a violet color light, a yellow color light, etc. So it also depends upon the color of light. So that is Snell's second law. We will come back to this law later in this chapter. So this is just an introductory lesson. So we are going fast, just reviewing or remembering the phenomenon of light which we have learned before. Now, during reflection and refraction, images are formed. So let us just discuss about or just discuss various kinds of images. When rays of light coming from a point falls on a surface and after reflection or refraction, if the rays meet at a point, or appears to diverge from a point, then the second point is called the image of the first point. This is a bit confusing when you read like that. But look here at this figure. Here, light from this flower is incident on a mirror. This is a curved mirror. After reflection, all of them join at a point, and there we can get the image of the object. We can get the image of the flower. So this is a case where the rays really meet or joins together. We will get an image then. Now, if the rays do not meet, this is the situation here when light is incident on a plane mirror. After reflection, they are diverged or they are separated. But they appear to diverge from, if we look from here, they appear to come from a point. Then also we will see an image here. So in both cases, we will see an image when the rays of light actually meets after reflection or after refraction, or when the rays of light appears to diverge from a point. So from these two situations we will get a image. Now images are of different kinds. Some are called real images, some are called virtual images. Let us see when a real image is formed and when a virtual image is formed. When rays of light coming from a point falls on a surface and after reflection or refraction, if the rays meet at a point, then the real image is formed. As this case, they actually meet. So a real image is formed. And when rays of light coming from a point falls on a surface and after reflection or refraction, if the rays appears to diverge from a point, then the virtual image is formed. Like here, after reflection, when we look from here, they appear to diverge from a point. Therefore, a virtual image is formed here. Now, real images will be inverted in nature. Now you can guess, when we look at mirror, what is the kind of image we see? Do we see ourselves inverted? No, we see ourselves erect, upright. So what we see is a virtual image, not a real image, like this. When we see ourselves, what we are seeing is a virtual image of ourselves. So it is erect, not inverted. Real images will be inverted, virtual images will be erect or upright. Now, real image can be caught on a screen. So here when we are seeing the reflected image from a, what kind of mirror is this? Where is the reflection taking place? In the curved surface, in the inner curved surface, right? So this is an example for a concave mirror. So from here, what we get is a inverted real image and it can be caught on a screen. So you can see it on a screen. So real images can be caught on a screen while virtual images cannot be caught on a screen. They can be just viewed directly. Then concave mirrors or convex lenses give real images, while plane or all kinds of images, all kinds of mirrors and lenses can form virtual image depending upon where we place the object. So I hope you got an idea what is real image and what is virtual image. Real images are obtained when the light rays actually meet after reflection or refraction, and virtual images are obtained when they appears to diverge from a point after reflection or refraction. And real images will be inverted and they can be caught on a screen, and they are formed by concave mirrors and convex lenses only, not by plane mirrors, not by convex mirrors, not by concave lenses. So virtual images, they will be erect and they cannot be caught on a screen, they can be just viewed, and all kinds of lenses and mirrors can form virtual images depending upon where we keep them, where we keep the object. So that's all for lesson 1. This is a short lesson and an introductory lesson. We will see in the upcoming lessons more details and up to date about the topics covered in geometrical optics. Thank you for watching.